imagine this is a cashew nut which we eat, right? Cashew nut. Now, you want to find out how much energy is stored inside this cashew nut. So we cannot directly measure because this does not radiate energy. So what we do is we use a colorimeter. Colorimeter. So this is a colorimeter. What we do is we start burning this cashew nut. Okay, we have to make sure that the heat from the Bunsen burner does not reach the container. The only energy which will be reaching this container is the energy which will be released when burning this cashew nut. Now we start burning this, and this cashew nut releases energy. This energy is then used to heat up this water. So before we talk about more in details about water, we have to understand the density of water is 1 gram per cm cube. So if we are taking 100 cm cube of water, that is basically 100 grams of water. How do we know? Density equals to mass by volume. Mass is equal to density into volume. So amader density, mass of the water is density into volume. Are you listening to me properly?
Yes, sir.
Yeah.
Yes, sir.
Yes, clear.
So the cashew nut is burned down. Suppose we have taken half of this, exactly half of this. Okay. Now, to heat the solvent / water, we also need to remember one important unit, that is specific heat capacity. Specific heat capacity. So what is specific heat capacity? It is the energy required to raise the temperature of 1 gram of solvent by 1 degree centigrade or by 1 Kelvin. So specific heat capacity is basically how much energy you require to raise the temperature of 1 gram of water or 1 cm cube of water by 1 degree. So specific heat capacity of water. Specific heat capacity of water is equal to 4.2 gram per Kelvin. So you would need joule per gram per Kelvin. 4.2 joule per gram per Kelvin. So you need to provide 4.2 joules of energy to raise the temperature by 1 degree
By 1 K.
or by 1 Kelvin. The change is 1. It could be in degree centigrade, it could be Kelvin. And I mean, for last class, I told you people that the unit here is not very important because we are measuring the change, right? We're measuring the change. So it could be in degree centigrade, it could be in Kelvin. So since it's a change, it's not very important. Now, imagine we have taken 100 grams of water. So if you need 4.2 joules of energy to raise the temperature by 1 degrees, তাহলে how much energy would you need to provide you would need to provide 100 grams with? So it's 100 into 4.2 into, suppose your initial temperature was room temperature, which is
25.
25, and now it has become 30. So what is the change in temperature?
5.
5.
So 100 gram into 4.2 into 5 is 2100 joule of energy was released by this half of the cashew nut. তাহলে একটা cashew nut, the one whole cashew nut is releasing how much of energy?
The double of 4K.
Double, right? So we can say that half of this, the cashew nut is 0.5 mole is releasing 2100 joule. So 1 mole or 1 cashew nut is releasing 4200 joule or 4.2 kilojoule. But আমাদের তো আর আমরা তো আর কেমিস্ট্রিতে আমরা ক্যাশনেট ল্যাবে করি, কিন্তু আমরা specifically what do we do? So in real life, what we do is we take a sample. We take a sample which is a liquid. Let's take octane. Again, I do not know how much of energy is released by this octane. So suppose here we know that we have taken, by calculation, we have taken 0.7 moles of octane. And ওইটার উপরে যে apparatusটা, এখানে we take a copper metal beaker so that it acts as a good conductor. Okay? So again, from here, we use this formula. The enthalpy change is equal to mc del theta. So m is the mass of liquid. C is specific heat capacity of water. Specific heat capacity of water. And del theta is temperature change. Temperature change. So here again, we took 50 cm cube of water. So it's 50, 4.2, and the temperature change was 7, 8. 8. The temperature change was 8. It could be 8, difference could be 8 Kelvin or degree centigrade. Not a matter of concern because we are taking the change. আমি বারবার কিন্তু এটা emphasize করছি কেন? Because you people get confused. It's a change. So তোমার 1 degree থেকে 5 degree তেও যেমন 5 change is 5. Similarly, 273 Kelvin and 278 Kelvin এর ভিতরে change কিন্তু it's still 5. And this is del theta. Del theta is the temperature change. It's not the temperature itself. So if now they ask you to find out the energy released per mole, how do you do it? 50 into 4.2 into 8. What is the answer?
1680.
1680.
80.
Joule per gram per Kelvin. So we can say that 0.7 mole of butane releases 1680. The 1 mole of butane will release how much? 1680 by 0.7. What's your answer? Divided by
2400.
2400. Joule per Kelvin, or you can write 2.4 kilojoules. So they usually ask the final answer in kilojoules. So just divided by 1000, that's your answer.
Sir, does the mass always have to be in grams?
Of course. It could be in kgs also. So kg hole তখন তোমার আবার সবকিছু
Convert
change
করবো।
হয়ে যাবে. If you take your water in kgs, তখন specific heat capacity of water in kg is 4200 kilojoule per Kelvin.
Per Kelvin.
So your answer is 2.4 kilojoule per mole. It should be per mole. So that means 1 mole of octane is releasing 2.4 kilojoule of energy. So we'll do a calculation of what we studied just now, okay? So a 1 cm cube sample of C14H30 was completely burned in air. The heat produced raised the temperature of 250 gram of water by 34.6 degrees centigrade. Assume no heat losses occurred during the experiment. The density of C14H30 is this. But আমরা কিন্তু আচ্ছা, so basically if we draw a diagram, the spirit lamp is made up of C14H30, right? And how much did we take? We took 1 cm cube of this. The heat produced raised the temperature of 250 gram of water. So here we had 250 gram of water. So always remember, del E is equal to mc del theta. So this mass is not the mass of the of the substance we are burning. This is the mass of the liquid which is being heated up. Okay, sir? It's the liquid which is being heated up. So what are we heating up here? Water or C14H30?
Water.
Water. So we would take the mass of water, which is 250. And what is the specific heat capacity of water?
4.2 gram per joule
4.2
per gram per degree Celsius.
into, what is del theta here?
34.6.
34.6. What's the total answer? What's your answer?
36,336.
36,000
336.
36 joules. Okay. Now, use the data above and your answer to 1 to calculate the energy produced by the combustion of 1 mole of this. So what information do we have of this C14H30?
Density.
We have the volume and we have the density. So then what do we need to convert it into?
We need to find the mass.
We need to find the mass. So mass is equal to density into volume. So density is 0.763 and volume is 1. So which is 0.763 grams, right? right?
Yes, sir.
Yes, sir.
Then what is the next step? You need to convert this into moles. How do we convert this into moles?
Divided by MR.
Number of moles is mass by MR. So we know the mass, which is 0.763. What is the MR?
198.
198.
Which is equal to 3.85 into 10 to the power minus 3 moles. So upon simple moles calculation, so 3.85 into 10 to the power minus 3 moles releases 36,336 joule of energy. So 1 mole will release how much? 36,336 divided by 3.85 into 10 to the power minus 3. What's your answer?
So 9.4 into 10 to the power 6.
Into 10 to the power 6 divided by 1000?
9.4 to 10 to the power 3.
9.4 into 10 to the power 3 kilojoule energy. Kilojoule per mole. Any confusion?
So why did we divide it by 1000 again?
It's better let's see. আচ্ছা ওরা এখানে মেনশন করে দেয় না, ওরা নরমালি মেনশন করে দেয় in kilojoule per mole. So normally give your final answer in kilojoule, because normally the final answer is so big in joule that if you divide it into kilojoule, it's a more workable answer, workable answer. Basically it's a shorter answer, that's it, and nothing else.
Sir, volume ki CM cube hobe na DM cube?
CM cube, because here we are taking gram. There are 2 units. There are 2 units. One is, it's either gram per cm cube or kg per meter cube. Usually we work out, we do the calculation in gram per cm cube. For specific heat capacity of water, it's 4.2 joule per gram per cm cube. But and if you convert into kg per meter, it's 42,000 kilojoule per kg per kg, or gram. So we have taken it in grams. So see how many times it has increased. You have to convert everything. So you have to convert cm cube into meter cube. You have to convert joule, gram into kilogram. So you have to convert everything. It's not this.